Given the ratio of circumference of a circle to the length of arc is 4, is ask what is the radius of the circle. So see how I'll connect this circumference of a circle and length of arc. We know that area of a circle, if you do the ratio of area of a circle over the circumference of that same circle, you notice that we have radius r over 2, because area of a circle is pi r squared, circumference is 2 pi r, so we are left with r over 2. Again, if you do area of a sector over length of arc of that same circle, area of a sector is theta over 360 times pi r square, while this one is theta over 360 times 2 pi r. So we still have r over 2. So therefore, we now see that area, the ratio of area of the circle over circumference of that same circle will be the same thing as area of the sector over length of arc. So therefore, which implies that if you now do area of a circle over, I'm cross multiplying, I interchange, this comes here, this goes over here, over area of a sector will be the same thing as circumference of the circle over length of arc of that same circle. So they gave us the ratio of circumference of a circle to the length of arc as 4 over 1, that's 4:1. And area of a circle, do you remember I told you this? From here you see that they will be equal to r over 2. Do you get? Because this equals that. This equals the same r over 2, meaning the equation now will be r over 2. So our answer is, therefore, r is 8. Do you get the logic? This equals r over 2. That same this equals r over 2. So I'm saying that this thing equals r over 2. So if you interchange, so here is r over 2. Since they equal, this equals r over 2. This same thing equals r over 2. So even if you interchange, this comes here, this goes here, they also be equal to r over 2. So that's why I made it r over 2. So our answer is 8C. Whereas the length of a chord, which is perpendicular bisector of radius of length 15 cm in a circle, is dash. Okay, let's draw the circle first. This is the circle. So they said radius. Okay, let's connect. So let's call it. So let's draw another perpendicular bisector of the radius. So meaning that so I'm saying that if here is the center of the circle, assuming this is the center of the circle, And they said the length of chord, let's call the chord AB. There is a perpendicular bisector of the radius. So from here you see that, okay, this C. You see that CO is the radius of this circle, and they told us it's 15. We can still draw the radius. The radius could be this. This is also 15. OA is also the radius. CO is also the radius, but it told us AB is a perpendicular bisector, so this should be 15/2, 15/2. And this is angle 90, perpendicular bisector. So as you can see, since here is 15 and 15, this is 15/2. The angle here should be 30, and the angle here should be 60. From 30, 60, 90 triangle theorem. The hypotenuse is always double of the one facing 30 degrees. So without wasting time, if we call this maybe ABC, let's call here A. A is 15/2 times √3. By our theorem, 30, 60, 90 triangle theorem. And if you have maybe a right angle triangle, that the angle here is 30, this is 60. If here is x, here is x√3. The one facing 30, if it's x, the one facing 60 is x/3. Y, the one facing 90 is 2x. So the ratio is 1:3:2. So that's what I applied here. So, and again, remember this is perpendicular bisector. So EB is also 15/2√3. So our answer, the length of the chord AB is just 15/2√3 plus 15/2√3. That's double. So the answer is 15/3. Our answer is C.